Transformations, we're going to change the size, location, or orientation. Okay? So how it looks. Those are the three ways we'll change transformations. Size, location, orientation. Okay? First, we're going to focus on a translation, though. A translation is a type of transformation. So think about the English language. If we're making a translation, what's happening? Yeah, sure.
You're moving the location.
Well, no, I'm saying like just with words. If I want to translate something with words, like not math.
So you're like changing the language?
Yeah, but do you change what it is?
No.
Not if you do it right, right? So you're just changing the language or changing where it's said so it changes dialect or something, right? So a translation is going to be a type of transformation with a slide, each point in the figure the same distance. So everything slides the same distance and in the same direction. Now notice, is there any like spinning or twisting of that at all? No, it's kind of like what's up is up, what's down is down for it, but you can move it all around. That would be a translation. So you're only moving up, down, left, right. No spinning, no flipping, just up, down, left, right. Two words you're going to want to know. We're going to have an image, and this gets a little confusing for a second. Image is the new shape, and then we have a pre-image, which is the old one. Okay? So the image is the new shape that you get. The pre-image is the old one. All right, the first one, the OG. Example one, we have this triangle ABC, and they want us to take our triangle and move it 1 right and 4 up. So 1 right and 4 up. So I'm going to start with B. You can start with any letter you want. I'm going to go 1 right and 4 up. Then I'm going to go C. 1 right, 4 up. Then I'm going to go A. 1 right, 4 up. So everything you slide everything 1 right and 4 up. What do you notice about my image compared to my pre-image? It's the same, right? I haven't changed the size, I haven't changed the shape, I've just changed where it is. This is called a rigid transformation. Now let's look at what happened to my coordinates. For my pre-image 1, -3, my image, A prime, is at 2, 1. My pre-image B, being 3, 0, B prime, is now at 5, 2. And my pre-image C at 4, -2, is now my image C at 5. Wait, I did B and C, didn't I? B was at, I messed that up.
Wouldn't it be 0?
No, B prime, my image B value is 4, 4. I mixed up my B and my C. And my C would be at 5, 2. I got you. I'm moving. Got my B and my C mixed up for a second. There we go. So is there a way, I'm asking for an algebraic rule, to get from my pre-image to my image? Is there an algebraic rule? Like something I can do to my x values. We're looking down here. Notice it said 1 right. What happened to all my x values? I added 1 to it, yeah. Then I have 4 up. What happened to all my y values? It's 4. So this would be the algebraic rule. X plus 1 tells me I'm moving everything to the right 1. Y plus 4 says I'm moving everything up 4. Cool? So it's given us triangle JKL at 0, 2, 3, 4, and 5, 1. So JKL. And here's our triangle. Now you could do this with any shape. We're just working with triangles today. Now we want this 4 units left and 5 up. 4 units left, 5 up. So what I want to challenge us to do is let's write the rule first this time. If I'm going 4 left and right up, what's my rule going to be, Lauren? We're looking down here. 4 left. What's going to happen to my x value? So 4 left. What's going to happen to all my x's? So plus 4 would send me 4, right? So how do I get to go 4 left? Minus 4, yeah. So my rule is going to be x minus 4. That gets us going 4 left. Henry, how am I going to go 5 units up? Yeah. Y plus 5 gives me 5 units up. So this rule says go 4 left and go 5 up. So let's do it. I'm going to use a different color to make it pop. So, and actually, I'm going to write my points first. 4 left of 0, negative 4. 5 up from 2, 7. So my new j value would be negative 4, 7. Okay, so for my k value, k prime here, 4 left of 3 is negative 1. 5 more than 4 is 9. I kind of like applying the rule and then graphing it myself instead of sliding everything. And then for my L prime value, for my image, 4 left of 5 is 1. 5 more than 1 is 6. So here's 1, 6. There's my L prime. So taking a look at my new triangle, is it congruent or similar? What that's saying is it the same size and shape or not? Is it the same size and shape? Yeah. So I would just circle congruent, same size and shape. And that's called a rigid transformation. We just slid it, right? Translation, slide it. So what I want you to do for example 3, everybody, is I kind of want you to work in a small group or people close by you. And I kind of want you to just roll through all of example 3 on your own. There's lots of parts, and this will tell me if we can just move on. So example 3 on your own, please.
So they already gave.
All right, friends. So there are the answers. To review, if it's an x and it's plus, which way? Right or left? Right. If it's minus, which way?
Left.
And if it's y plus, what is that?
Up.
And if it's y minus?
Down.
Yeah. You don't even have to write that. Like, I think you just intuitively know that at this point, right? So we use that rule to kind of help us. It's another mode of communication. I'm a big fan of the rule. Did you notice I use it a lot for like just getting my new points and stuff? I prefer it than pulling points from the graph myself. All right, we're going to have to roll into reflections next. Let's take a little stretch break real quick. Everybody get out of your seats. So we're looking at reflections, friends. And reflections are kind of cool, and you probably already know what they are a little bit. But we're going to get some basics down. It's when we flip a figure, okay? We're flipping the figure over a given line. And this line has a special name. It's called the line of translation. No, reflection. I don't know why I said that. The line of reflection. It gets a fancy name. You know it's the line of reflection. It's because it's the line you reflect stuff over. Kind of has a pretty easy name if you think about it. And so reflecting, we're like flipping. And I'm going to give you some advice. In first hour, didn't take the advice perfect, but they made some good mistakes. So there's going to be you're going to have some confusion when you see the letters X and Y, because X usually means which directions?
Right,
Left and right, okay? Now for flipping over the X axis, which we're about to do, how does your image change?
It's
up and down.
Up and down.
Right.
If you're flipping over, so we're going to flip over this line, it's going to flip up or down, which, is that going to change your X values? No, so even though we're flipping over the X axis, if we're only moving up and down, it's not going to draw our X's. And let me show you what I mean. So the B would stay there. If I'm going over the X, my C would go up there. And if I'm going over the Y, the X, my A would be right there. Whoops.
Didn't the C change that?
The C did change, but not left and right. Notice this whole thing did not move left and right, right? Vertical line, vertical line, vertical line, still the same spot, left and right. Yeah, it's kind of like there's a string there and we flip the other side of the string, right? So the point I want to make is what gets tough here is when students want to try to memorize something, they're like, oh, it's x, it's left and right. Did it move left or right at all if I flipped it over the x? Now, so I always do this with my hand. Make sure you zoom it up and down only, right? Okay? So, let's look at the original coordinates and the new coordinates. So let's start with A. Our original of our pre-image was 1, -3. And my image is 1, 3. So what's the only thing that changed? The y changed to its opposite. So let's keep that in mind because we're going to have to develop a rule here, right? All right. So let's look at letter B. 3, 0 became 3, 0. So if we changed y to its opposite, what's the opposite of 0? Just kind of 0. There's no negative and positive 0. So let's see if it holds true with C. We got 4, -2. And we've got 4, 2. Did my y just change to its opposite? Yeah, so our rule is going to be xy becomes x opposite of y. And all that's saying is it's flipping up or down, right? The only thing that's changing is my y value to its opposite. My y value was below, the opposite of the negative is positive, right? If it was up and I flipped it down, the positive would become negative. Is it congruent or similar? Is it the same size and shape?
Yes.
Same size and shape. And with triangle ABC, let's just write down all 3 coordinates already. So let's go right to coordinates. A still is 1, -3. B is 3, 0. And C is 4, -2. Okay, this time we're asked to reflect it over the y-axis. This is the all your single ladies one. So if we're going over the y-axis, what's changing? And we're going to guess if when we went over the x, the y changed to its opposite. If we're going over the y, what probably will change to its opposite? X. So let's try that. We're going to try that rule, -xy. Let's see if it works. So let's write what that would equal for A prime. That would equal -1, -3. I just changed the x to its opposite. No, I didn't. Yeah, I did. So -1, -3. Does that look like I flipped A over the y-axis?
Yep.
Okay, so let's try it for B. 3, 0. If x becomes its opposite, -3, 0. Does that look like I flipped B over the y-axis?
Yep.
Looking good. For C, x is going to become its opposite. -4, -2. Let's take a look. Yeah. Congruent or similar? Congruent. Same shape. Different orientation, right? We flipped it. It's different than a translation because I can't get here by just sliding, right? Could you ever get there by just sliding? Just translating, never.
No.
You would need a flip to change that orientation.
Not unless it was
You couldn't
You
because
could because you'd have to.
your angles would never match up. All right, I want you to try this next page, all of example 3 alone, and then we'll be done.
Wait, so just example?
All right, friends, even if you're not done, we're going to start getting rolling through these. So the first thing we're asked to do here is to go over the x-axis. And so that's changing things up and down, correct? So I like to write my rule. So y is going to become the opposite, and I actually like to just write my points first. Okay, so now I'm going to go draw my figures. I've got J at 0, 2, K at 3, 4, and L at 5, 1. But here's my triangle. And I already know the points on my image because I applied my flip already by changing all my y's to the opposite. So the big check is it the same or different? Shape, size and shape. It's the same, it's congruent, right? These are rigid transformations. So let's go down here. I'm going to list my coordinates I just had. And now it wants to go across the y-axis. So across the y-axis, what's going to change, x or y? Across the y-axis, what's going to change, x or y? The x is going to change to its opposite. Right? I got to plug in my computer real quick. 1 second. So, left and right. Do you see me doing this thing with my hand? That's to keep in my head straight. If I'm going over the y, my x is changing to its opposite. So I just like to get my new points straight away. So x to its opposite, x to its opposite. Then I like to go do it. So then j prime, -3, -4. There's my k prime. And -5, -1, there's my L prime. And I look, and compared to my original, my triangle looks to be congruent still, right? Same size, same shape. So is there a combination, a different combination to get there? Instead of over the x over the y, what could I have done?
Went over the line.
Yeah.
The X.
Over the river and through the, or wait, over the y and over the x would have also got me there, right? Also, I want you just thinking ahead to the future. What happens if I took this whole thing and like spun it? Let's see if I can do it. Let's see if I can do this. One sec. We're trying something crazy here. Okay, what happens if I took the whole thing and I spin it? What do you notice about the red and blacks? What do you notice about these two and these two? They just swap places, right? I spun it a half turn. Just keep that in mind for future lesson, all right? That's all we need, guys. Your homework's on Desmos. You can find it assigned on Desmos, student.desmos. Let's get after it.